All right, so using these properties of integrals as well as these pieces of information at the top, let's see if we can determine these definite integral values. So these are going to be a little bit different than the ones we've seen in the past because normally we've had to work backwards by hand using that reverse power rule process or maybe a special antiderivative. But for these, we don't really have that information available to us. We just have some area values given to us for f of x. So the area under the f of x graph from 0 to 3 is 6, and the area from 3 to 7 is negative 8. So using those pieces and the properties, let's see how far we can go. If you take a look at the first one, notice how we're going from starting at 3 and we're ending at 0. That's kind of working backwards. Okay, it's not in a typical fashion of a number line where the numbers go from least to greatest. So in this case, I technically want to switch the bounds. Okay, I want to go from 0 to 3, but if I switch the bounds, I have to negate the area. So looking at this definite integral is actually the opposite of the integral from 0 to 3, which we already know is 6. So I need the opposite of 6, which would be negative 6. All right, looking at the next one, we want to find the total area from 0 to 7. And looking at the information we have, we know the area from 0 to 3, but we also know the area from 3 to 7. So notice how this first interval ends at 3, where the next interval begins at 3. So since they're ending and beginning at the same spot, we can do a total accumulation of these two values. So rewriting this as one of the properties, I would want to go from 0 to 3, and then I can add the area from 3 to 7, because that'll give me the total area from 0 to 7. So that would be 6 plus negative 8, which would give me negative 2. All right, looking at the next one, notice how immediately I'm hoping you notice that the bounds are the same. So we are beginning and ending our area calculation at the same point. Okay, we don't necessarily have an interval this time because we're beginning and ending at the same spot. So our total area would actually be 0. Looking at the next one, we might be able to do a combination of some properties here. The first thing I notice is that my bounds are switched. Okay, we're starting at 7 and ending at 3. That's not really in numbered order. So if I switch the bounds and go from 3 to 7, I have to negate the area value. I also notice how I have a constant or a coefficient in front, so I can think about factoring that out. So really I can put a negative 3 in front of this integral. So this notation is basically telling us we're going to take negative 3 times the area under the f graph from 3 to 7, which we already know is negative 8 from the top. So overall our area value for this definite integral would be 24. All right, looking at the next one, our bounds are in order, which is good, starting at 3, ending at 7. But I notice how I have multiple pieces that need to be evaluated before the dx. So utilizing a property, I can break this up into individual integrals. So I'm going to start with a 2 and end there. And then I'll move on to the next term, that 3 f of x. So I'm going to work backwards from both of these one at a time. Now for the first one, since it's just a 2, I can definitely work backwards from that with respect to x. So this would be a 2x, and I'll throw in the bracket with the bounds. My next integral, I might be able to use a property here by pulling out that 3 as a coefficient. All right, I'm going to continue to work down here just because I'm running out of room. If I look at my first term here, I need to evaluate 2x from 7 and 3. So according to our fundamental theorem of calculus, I'm going to plug in my top bound first, which would be 14. Then I have to subtract what I get when I plug in the bottom bound of 3, which would be 6. And if I continue through my calculation, I need to add 3 times the area from 3 to 7, which we know from the top is negative 8. So I believe altogether this is going to lead us to an area value of negative 16. Looking at the next one, we're going from -3 to +3, the area under the f of x graph. And for this one, they want us to assume, or we know, that f of x is even. So notice how we're beginning and ending at the same valued number, just one's negative and one's positive. So we have to be careful about what this even function means. And that means we have the same area to the left and right of the origin. So if that's the case, we can break this up and go from 0 to 3 and simply double it. And notice how that's going to be beneficial because we know from 0 to 3 the area was 6. So if we double it, we'll get 12. So for our last one, it's very similar. This time we're just going to assume that it's an odd function. So that's telling us we have the same area above and below the x-axis, and since we're beginning and ending at the same numbered value, just one negative when one's positive, we're going to have the same area above and below, which means our total area is going to be 0. We do have to be careful though with these last two, because for instance, if this said -3 to 4, we would not be able to assume that the area value was 0. And for instance, from -3 to 4 for this one, we would not be able to assume that it's exactly double. So we have to make sure that we have the same numbered value if we're going to use that even or odd property, just one's negative and one's positive.